Hi, my name is Shraddha Rathod, and I will be talking about technologies behind autonomous vehicles. The big question is, what if you never had to drive again? Well, thanks to these companies and others, that future might be in sight. Waymo, more commonly known as the Google self-driving car, and Volvo have already introduced pilots for their self-driving technologies. But why the self-driving car? Well, without us in control, we would have less human error, therefore less accidents in traffic, and in the end, a lower fuel consumption rate. On top of that, we can be more productive without having to concentrate on our driving while we're commuting anywhere. So companies can go about designing their cars in different ways, and they do, but the underlying technologies are pretty much the same. Here you see images that are specific to the sensor placements of the Google car, but the descriptions I'm about to give are overarching to all companies. These are the 5 most common technologies used in autonomous vehicles, and they work in cohesion to be able to get a car from point A to point B without any accidents. The first one is called LiDAR. The LiDAR can determine a 3D map around the autonomous vehicle so that it can avoid any future obstacles that might occur. The camera typically monitors lane marking so that the car can stay in the lane, and also monitors obstacles right in front of the car. So if a pedestrian jumps in front, it can stop and not hit the pedestrian. The third one is radar. Radar typically monitors speeds of the cars around the vehicle so that the autonomous vehicle knows whether to slow down or speed up, and also when to change lanes. The fourth one is a GPS, which we're all familiar with. It pretty much determines the best route to get from point A to point B. And lastly, the car uses ultrasonic sensors, usually when the car is in a slower speed, like when parking, so that it can avoid walls and other pedestrians. But today I'm focusing on LiDAR, or light detection and ranging, because it relates back to some concepts that we've learned this semester. LiDAR systems are very similar to radar, the only difference being that LiDAR uses light waves or optical waves, while radar uses radio waves. The technology is able to detect object distances and create detailed 3D maps that are crucial for autonomous vehicles. These self-driving cars use an HD LiDAR system. It consists of 64 laser beams. The sensor here rotates and emits these laser beams for a 360-degree visual. When the lasers reach the target, the signal is often scattered, and the sensor can read the re-radiated energy from the target. Then, from this, object distances can be calculated by measuring the time it takes from light waves to be transmitted and then received, and by using the speed of light. Here you see an HD LiDAR system that generated a map, and you can tell that it can specify cars from human beings. It's very detailed, and it gives the car more capabilities and machine learning abilities in the future. So, to relate this back to class, LiDAR highly depends on wave reflection and transmission theory in order to find objects and distances. These sensors transmit unbounded EM waves through a lossless medium because there's no transmission line or wire, and it travels through air. Following these properties, whenever a target is reached, the wave is then scattered and reflected. Since cars are moving objects, LiDAR uses wave reflection theory similar to that of a Doppler radar, which also moves, using movement and angle shifts to find object distances, as you can see in this diagram. In a typical self-driving car, each LiDAR radar has its own detector, and each LiDAR laser detector pair is precisely aligned at predetermined vertical angles to give it a 28.6-degree vertical field view. Now, these predetermined angles are determined using equations describing wave reflection from a moving source, as shown in this diagram here, and in equations that relate back to what we've learned this semester. So, all in all, autonomous vehicles are very beneficial because it can reduce accidents and take out human error. Most self-driving cars have 5 basic technologies: LiDAR, cameras, radar, GPS, and ultrasonic sensors. And lastly, LiDAR uses ultramagnetic waves in the form of light to make detailed maps of the vehicle surrounding, which is a new technology and very crucial to the success of the autonomous vehicle. We learned a little bit about this in class, and now we can apply it to the real world, so that's really cool. Thank you.